It's time to do the turbos. I'm in the process of swapping a big block Chevy 454 into my Volvo 1800 ES. This is not the first thing I've done to my build. I've actually been working on it for nearly a year. That said, there's a reason for that. My previous workshop wasn't exactly any place to be building engines, much less recording. Now that I've finally built a new shop, I can actually try to make videos. Now the plan here is to build both adapters on the inlet and outlet side. On the inlet side, that being a T3 to a 3-inch V-band, and on the outlet, that is a 5-bolt internally wastegated flange to a 3.5-inch V-band. These are a pair of T3, T4 turbochargers that are internally wastegated, as you can see I'm playing with there, and I'm removing that flange and making my own for the purposes of shortening the overall length of the turbocharger to actually get it to my desired exhaust size, being 3.5 inch. When I do research online, it says 3.5 inch would be adequate for the power level I intend on running, which is about 800 combined or 400 per turbo, which is what they claim to be able to flow. Now I purchased a Max Speeding Rods Turbo because they have a pretty good reputation from what I've seen so far, that they actually balance their turbochargers, which is by far the most important thing. If not, then the turbo doesn't last very long. Now I sized these turbochargers because they're turbochargers, and like many other cheap turbochargers on eBay, are copies of Garrett designs, and in this case it's the T3 T04E design from Garrett. So, looking at any Max Speeding Rods turbocharger, if you can find the same one on Garrett's website, you also have access to the same technical information that anyone who purchases a Garrett turbocharger does too. That's not to say they'll be manufactured to the same standards, but it gives you a good idea of what the turbochargers can do. Starting with the disassembly of the turbocharger, it's pretty self-explanatory. That's why I don't really feel the need to give a voiceover specific to what I'm doing. It's just a whole lot of nuts and bolts, and everything pops right out, and it's going to pop right back in. I'm disassembling the turbocharger to paint it. The turbine housing and the center are both cast iron, and they're covered in a bunch of preservative oil. This is done to keep it from rusting in storage and shipping, but it burns off the first time that you use it on your car, and then it's susceptible to rust. I don't like that because these turbos are going to be visible in my engine bay, and I have Cerakote, which is a very high temperature paint that I'm going to be using to paint them with. Now I plug all of the oil feed, return, and the bearing holes, these are journal bearings, on the center to prevent any sand from the sandblaster I'm using from getting in the holes. You have to sand properly in order to get any reliable paint adhesion, and unfortunately on the raw cast iron finish of the turbine housing in the center, it's pretty much impossible to do without a sandblaster. Lots of brake clean, compressed air to get all the sand off. The compressed air gets most of the sand off, but I do want to clean it again right before I paint. Under 24 hours, I removed the masking tape. I found that this prevents any of the paint coming off. Of course, if your paint is properly adhered, this isn't something you should need to worry about too much. If you wait too long for the paint to fully cure, the paint loves to stick to itself, but not so much the part you applied it to, and it can peel off and create a really uneven edge if you don't get that masking tape off pretty soon after the paint is applied. There's a chamfered hole that allows the sealing ring on the turbine side, the shaft, to just pop right in. You don't actually have to compress the sealing ring. There is no specific torque, however I heard that quarter-inch shaft turbochargers, which is what I believe this is torqued to around 20 foot-pounds, and I put red Loctite on it just to make sure that turbine shaft nut doesn't come off. Now here I'm grinding these are pre-made T3 adapters to 3-inch V-band I got off of eBay. I'm grinding them to meet the T3 outlet flange. Even though these turbos are well balanced, one thing I noticed was that the machining wasn't exactly the most consistent between the two. There were some holes that didn't really look like they were supposed to be in that position, like they were a bit misaligned. Here I began the fabrication of the outlet flange adapters. I started with this 1/2-inch plate that I made in Fusion 360. I uploaded it as a canvas and then just traced it out, sent it to Suncut Send, and had them make it out of 1/2-inch plate. I used die-chem and the adapter, generic pipe reducer, from the 2.5-inch outlet. I ground a taper into the flange that I'm going to be smoothing out when I weld it. I used filler, but honestly, in hindsight, I don't think I really needed filler. Cutting off the V-band because I'm going to be using my own flanges that have a lip. I wasn't a fan of the ones without the lip. They don't fit up as cleanly as the ones with the lip do. Welding it without filler, I get much smoother and cleaner results. Don't have to add as much heat, and it looks a lot better. Although these are steel parts, so unfortunately they will have to be painted over. Here I weld the inside of the second flange. I didn't use filler this time and it turned out so much smoother. Then I don't have to grind as much material away or when I smooth the inside of the pipe adapter. Here are the T3 flanges. I'm going to be replacing the V-band with, again, a lipped one that I bought generic just off of eBay. I didn't do the cleanest cut here, so I ended up having to grind quite a bit away. The file is there just to get any burrs off, but I realized pretty quickly that I needed to take it to the belt sander. Once again, not using filler comes out a lot better. I still need to work on my consistency in TIG welding. Overall, I think this project turned out pretty well. That isn't to say it is not without its fair share of issues. Because of the inconsistency with how the holes were drilled, the machining on the turbine housing that I mentioned earlier, one of the flanges doesn't line up particularly well, despite me making them the exact same. That said, it's not like my 3D model was very precise. They actually had to send me like 4 emails because my design was so messed up. It is made of steel, and I would have really liked to make it out of stainless, but at the time I didn't know Ace Race Parts existed and that they sold stainless pipe reducers that fit my application. These pipe reducers would have also had a less aggressive taper, making it so I would not have had to cut the 3 bolt holes and actually remove one entirely because the head of the bolt kept hitting the reducer. I actually do have a bunch of other projects lined up. For example, this bandsaw. I already have a video nearly complete, and I will be doing an engine assembly video with a new valve train and many other things. With that said, I really like how these new parts look, and I think they're going to be a great fit for my engine when it's done. That's what I would say if I was actually going to use them.